You have learned how to calculate the average atomic mass from isotopic masses. Now, how is the mass of an element related in a pure compound? You also learned that according to law of definite proportion, the ratio of mass of the constituent element in a pure compound is always constant. So in this lesson, you will learn how is the mass or the percentage of each element helps to find the formula of a compound. We will learn two types of formula, empirical formula and molecular formula, and how to calculate from experimental data. There are three steps for determining the chemical formula. The first one is to determine the percent composition of all elements. Second one is convert this information into moles and find the empirical formula. And the third one is to find the true number of atoms of each element in the compound. That is going to be the molecular formula, the normal formula we use every day. First, let me explain how to calculate the percent composition. When chemists work with a new or unknown compound, one method they use to determine the chemical formula is to determine the percent composition. Let us see how this percent composition is calculated with the formula here, which is percent of element equal number of atoms of that element in the compound times the atomic weight of that element divided by the formula weight of the compound, that is the molecular formula, and times 100. This is a formula. It's not in the formula sheet, so you have to remember this one. So let's see an example here. To find the percent composition or mass percentage of iron in Fe2O3, what we will do first, we will write the percentage of iron equal. How many atoms of iron are here? We can see 2, the subscript 2. So 2 times the mass of iron from the periodic table, which is 55.85. That times 100 because it's percentage, divided by the formula mass of this compound or molar mass of this compound. That's going to be 2 times 55.85 for iron, that is from the periodic table, plus 3 because that's a subscript here, 3 times each oxygen is 16 grams from the periodic table. So add them and here multiply and you will get this 111.7 grams divided by 159.7 multiplied by 100, which equals 69.94%. Similar to that, you can find for oxygen. There are 3 oxygens, so 3 times 16 times 100 divided by, you already calculated the molar mass, so that divided by 159.7, that will equal 30.06%. So how will you check that your calculation is correct? Once you have the percentage of each element in the compound, when you add the percentages, it should equal 100. That's the way you are checking. Sometimes it will be a little bit less than 100 or a little bit higher than 100, say for example 99.97 or 100.1, something like that. So then you can say the calculations are correct. Okay, that's one way to check it. And also you can actually find, if you know the mass percentage of iron, you can actually subtract from 100. 100 minus 69.94 will give you the mass percentage of oxygen. So here there are two questions for you to do by yourself. Pause the video and do the calculation for question number 1 and question number 2, and we can check the answer later. These two vocabulary are important. You should know what is empirical formula and you should know what is molecular formula means. So empirical formula is the simplest whole number ratio of atom in a compound, just like law of definite proportion. The ratio, you're finding the ratio. It's going to be constant for each compound. The mass of elements in that compound will have a fixed ratio. And the molecular formula is the normal formula we are using, the chemical formula that shows the actual number of atoms in the molecule. So we are learning these two formula, but there is another one called structural formula that we will discuss later. So now we are concentrating on how to calculate empirical and molecular formula from the experimental data. Here are some examples. Molecular and empirical formula of some compounds here. This is the molecular, the actual formula we normally use. And this is the empirical formula, which is the simplest formula. So you can see the subscript here 2 and 2. So each subscript should be the simplest ratio. That means the smallest ratio will be 1 to 1. So the empirical formula will be CH. Similarly here C6H6, 6 is common here. So the empirical formula will be CH. But in this case, you can see 1 and 3, so there is not common factor. So we will write the empirical formula as such. So for ammonia, the molecular formula as well as the empirical formula will be same. And the rest of it, you can see that it is not the same. There is a common factor, so you will find the empirical formula by the simplest ratio. So here again, check for understanding. Do this one by yourself and we can check the answer later on. Pause the video and do it. And now, so let's see what is empirical formula. And as you know, this is the simplest formula. I'm giving here one more example. And then we will see a question here. Okay, so which are the steps? Let us see. So these are the steps we have to follow to find the empirical formula. First step is, from the question you will get the percentage, which is, you can actually take it as a mass. So even if it is in percentage, don't worry, just take the number. Okay, and then that mass, you have to convert it into moles. You know how to convert mass to moles. You have to get the molar mass from the periodic table, and then mass divided by molar mass will give you the number of moles. It's not a big deal, you have learned that already. And the third step is divide by the smallest, because we need the simplest ratio, right? So once you get the moles, you have to look for the smallest one and then divide each mole with that smallest number, smallest number of moles you calculated. And then multiply. If it is not whole number, just multiply in order to get a whole number, because we cannot have fraction in the formula. Answer. And now for example, here you can see that a compound is 24.7% calcium, 1.2% hydrogen, 14.8% carbon. So let me get the highlighter here. So we will write this one, we will write this one, and we will write this one in the table. We did that one, and you can write the masses of each one. Okay, calcium, hydrogen, carbon, and oxygen. Oxygen is here. And now write the empirical formula and name the compound. So let's see. So we took that percentage as masses here, and now we looked it up in the periodic table to get the molar mass, and now find the number of moles. So mass divided by molar mass will give you the number of moles. So here it is. And after that, we will look for the smallest one here. The smallest one is 0.62 and divide by the smallest one. So each number of moles we got, we will divide with the 0.62 here. So the next one, 1.2 divided by 0.62. You can simplify that. This is 1.98. This is 1.93. Very close. You can see that. Next one is 3.7 moles divided by 0.62. That is 5.96. And now the last one will be definitely it is 1, because we are dividing with the same number. So now look at that. 1.98 is very close to 2. So we don't have to make it multiply or anything. We just round it to 2. The next one also 2. The next one will be 6. And the next one is 1. So the final ratio of carbon, hydrogen, oxygen, and calcium will be, remember, the number of atoms in a molecular formula is a multiple of the number of atoms in an empirical formula. That's what we have found in the previous examples. So if we find the empirical formula and we know the molar mass for that compound, we can find the molecular formula. So for example, the empirical formula is CH2O, and if the common factor for the subscripts were 6, we just will multiply with that number and we will get the molecular formula. Just reverse we are doing. So we were having the molecular formula and we found the common factor here. We were dividing 6 over 6, 12 over 6, 6 over 6, and we were getting the empirical formula. Now we are doing the reverse. All right, so let's see. And now here the molar mass is 6 times 12 plus 12 times 1 for hydrogen, 6 times 16. These numbers are coming from the periodic table. I did not write 1 for hydrogen because it's just 12 times 1 is 12. So we don't have to write that one. And for carbon it is 12 from the periodic table. And that divided by the empirical formula mass. Empirical formula carbon only 1, so it is 12. There are 2 hydrogen, so 2 times 1 is 2, and there is only 1 oxygen, so 16 times 1 is 16. So that equal, when you simplify, you can see 180 divided by 30, so that is 6. So this number will be given, that is 180 will be given in the question. So from your calculation, you just have to find 30 and then you will get that number 6, and then you will do this calculation for finding the molecular formula. Okay, I will explain with an example now. So that is represented as n, that 6 is represented as small letter n. Don't get confused, we are using n for number of moles, and now this one here n is just a integer number. Okay, so that equal molecular formula mass divided by empirical formula mass. Here is an example to calculate the molecular formula. So in this question, the empirical formula of a compound was found to be CH. They gave you the empirical formula. It has a molar mass of 78 grams per mole. They gave you the molar mass as well. And they are asking what is its molecular formula. So how to solve these ones? First start with the n. To calculate n, we need molecular formula mass, which is given as 78. And now we need empirical formula mass that we can calculate from CH. Carbon is 12 from the periodic table, and hydrogen, the mass is 1 from the periodic table. So 12 plus 1 is 13. So substitute in this one, n equal, or the whole number multiple equal 78 divided by 13, that equals 6. And now what we will do to find the molecular formula, we will write it as empirical formula times n. So that equals CH times 6, that equals C6H6. So that 6 is coming as subscript here. That's going to be your molecular formula. And now do this question by yourself. Pause the video, read the question and do it. So here the steps are first to find the empirical formula and then find the molecular formula. This is a combination. So you have to find that empirical formula using that table. First convert the percentage to mass, that is mass divided by molar mass will give you moles, and then that moles you find the simplest ratio and then find the empirical formula. They gave you the molecular mass, and then molecular mass divided by the empirical formula mass will give you n. After that you can multiply the empirical formula with that n, you will get the molecular formula. So do it, pause the video and do it and check your answer later. Here is another one. Try yourself. Pause the video. Again, you have to first find the empirical formula and then molecular formula. And they gave you, did they give you the molar mass? Yes, they gave you the molar mass. Here you go. Molecular mass. Okay. So pause the video and check the answer later. Here is the answer for check for understanding in the previous slide. Here is the answer for the other check for understanding. Here is the answer for another check for understanding question. Hope you all got it right. And now move on to the next lesson.